Then let's welcome Leo to share the more details about the data analytics with us. Leo, thanks you.
Hi, hello everyone. Good afternoon. My name is Leon. I work on some of the data analytics program, and myself is working as a data scientist in Silicon Valley company for LinkedIn. So today, given a short time, I'm just going to walk through very briefly what is the data analytics program. I'll briefly talk about what is the essential skills that were required for entering this job field. And then the second is the job market. And then the third is a little bit demo of what type of projects we'll be working on. So the three topics: core, knowledge, and skills, and then job market for data analytics, data scientists, or sometimes we call it machine learning AI. So it's kind of an interface to link both computer science and the business. And then the third thing is career planning in that domain. So before we dive into these topics, I'd like to briefly follow up on what G just mentioned, why this certificate program can be part of both programs. What's the connection of data analytics to MBA and computer science? Think about traditionally when people talk about any type of job, like consulting, when people from MBB background, they tell what is the problem, what's the proposed solution for that. So they tell you about the direction, but they don't tell you the exact solution backed up with data, like how to solve the problem. So nowadays, that data-driven solution and the mindset is becoming more and more widely accepted across all domains. So that's the reason why we believe data analytics could be part of both business side and the technical or computer science side. So let's dive into different topics one by one. Feel free to interrupt me if you have questions. We're open to discuss all the time. So the most direct thing is about data visualization. It's for data science, it's all about storytelling, because eventually you're going to share with the stakeholders in company, in client-facing environment. You're going to tell people based on your numbers, based on your models, what's the insights, what is the decision, what is the story you want to share with your audience. So one of the core knowledge and skill is about data visualization. So nowadays, you can think more broadly, like UI, UX design, how to put the buttons, how to design your workflow will play a very important role to affect people's feeling. And then more importantly, like CSS, HTML, all those traditionally front end, what we call front end design for software engineers, could be integrated as part of like the data workflow as well. And I don't know how familiar you are with, but like with Shiny, with R, with Tabular, a lot of more advanced Excel, right? We can call it more advanced Excel because you can manipulate the data and you can show, for example, how many of our students, let's say we become more mature in the later stage, and we want to think about like how many of our enrolled students are from Asia, from Europe, from Native America, from US and Canada, and then what's their occupation, what is their background, what is their professional domain they're from. So you want to tell those story with a dashboard, with some interface. That's the overview, why data visualization is the first step and the most direct knowledge and skill is needed for the data analytics program. Okay, next one is the database system. For sure, like many of us can write SQL or like Hive. Nowadays, people move to Spark. Whichever language you use, the key topic behind is relational database, right? So think about how to explain a simple concept to third-year grade, or like think about how to provide a clear logic vision to summarize. Hey, here are the departments, and here are each employee or each student, their background, what's their interest or customer information, whatever you want to store is going to back up like either your front-end visualization or your back-end algorithm, because we need the data pool to be enriched so that you can train models or you can tell stories. Next part will be nowadays popular topic like model building, machine learning things, right? When we gather those data, suppose we have historical data stored either by SQL, by Hive, by Spark, and then you can try to extract some feature and try to make predictions, let's say credit score, right? Whether you should approve someone's application for a credit card or mortgage, loan, all those things. Or make a prediction for housing price. Let's say, what is the housing price in next season, or like the stock price. And then from time series perspective, like the stock price is up or down in the following month, or it's from unsupervised clustering, where we don't have a ground truth. We just want to categorize, let's say, our audience into 3 groups or into 6 groups. But we don't know what are the exact label to call those people. So suppose, let's say, Amazon or any e-commerce site, like in China, Alibaba, right? They want to learn consumer behavior and try to summarize what is a typical consumer behavior. What is the pattern look like? So probably it varies a lot. Let's say someone, some lady in her 30s might have very different behavioral pattern than like old man in his 60s, or in different area, like rural area, in which part of the country, and what's their occupation, what is their education, income, all those features are going to play a very important role for their purchasing behavioral patterns. So after this feature engineering, we have like training part, validation, and hold on for test. Right? So many of you might be at least heard of some of these terms nowadays. Like we have the parameter tunings and try to build a model. The essential task is to teach the machine or teach your program to learn as humans do. Like try to summarize, okay, if we get someone having 3 years working experience, have like, let's say monthly income over $3,000, or he has living in a neighborhood for more than 1 year, and has a good record, has some social security, has at least a valid bank account. When gathering these features, okay, the system knows that this person is reliable. We can consider approve his application for credit card. So this is teach the system to think about it and have the output. So this is the whole logic and overview description of what machine learning is doing. So you can see that machine learning is going to, or model building part is going to link front end and back end, where front end is about the storytelling. You have that output, you have that data visualization to share with stakeholders. And then from the back end, you have the algorithms, like how to code it, right? How to design your system, like store the data, query the data, etc. So even more step forward, besides machine learning, people talk about artificial intelligence, deep learning. It's just an enhanced version of doing the way to teach computer to learn, right? So deep learning has been best explored in 2 areas. One is computer vision, the other is natural language processing. So it's how we understand the world and how we interact with the world and how we want machine to act as humans to perform the daily tasks, to recognize a pattern, to translate a language from Chinese to Arabic, from Spanish to English. So this is a enhanced version of the model building part, and we are likely to have some exposure to these topics as well in the data analytics program. So last part, but not least, is more towards the intersection between software engineer and data analytics or data science domain, is the data structure and algorithm thing. So many of these data structures you might heard of, like how we write a efficient data storage or how we have a fast algorithm to like conduct some tasks like search or sort or dynamic programming, all those things. So there is a not a so standardized way for data analytics, for data science. Not like your software for Google, for Apple, for Facebook. It's pretty common language. Like everybody is working on similar tasks. But for data science, it could vary a lot. So someone working machine learning, data science in Google might be very different from someone working for the same task in Amazon, because their story will be different. But it's always good to have a more general skill to back you up. Okay, so after the first session, we talk about the job market for data analytics or data analyst, data scientist, anything related to data science domain. So nevertheless to say that nowadays we are observing a more tightly connected relation between academia and industry. So let's say if someone is from medical background, someone is from social science background, doing academy, doing research in academia field and doing industry field is completely different. It used to be the same for tech companies, for data, for people, for statistician, for software. It used to be the same. Like some professor or some postdoc in Harvard, in Princeton, in Caltech, they're working on developing fancy or very advanced algorithm, but not focus too much on deployment or on its application in daily work. But nowadays, it's very connected. Like people are doing research in Berkeley, in Cornell, and those research topics could be easily scaled up and applied in a business scenario for Google, for Facebook. So that's a new trend for data science. Then what is the ROI, right? So I'm not going to talk too more for our program, but just in general, what's your input? Like how much tuition you pay for getting yourself prepared in the data science domain or in business, in computer science? We have some background to the data analytics field. And then what is the potential outcome if you can launch your career in some of the big tech companies? So it's a good investment, right? So education is always an investment. It's a long-term, like you put the money for building yourself to have better background, to have more core competency so that you can launch a successful career in the long run. And the trend. So this is for school. For how many schools in the US are opening a new data science or data analytics or business analytics program? So for people in industry, working professionals, why do I care? Why do I care how many schools are running new program? I've already graduated from school for 10 years. I don't care this. But this is the future. This is something as an indicator telling you, okay, what are the kids interested in? Why schools are opening new data science program? Because there is a demand in behind, right? Because Google is hiring. For students on the Zoom, sorry for the pause. We have some connection issue. So we're back to this trend in the data science or data analytics program. So you can see there is the trend, like Harvard is opening a new master in science, in data science. Berkeley is heavily investing their efforts to bring more data science program, online, part-time, or
so new trend, Harvard new program, Master of Science in Data Science begins to.
Yeah, we can. Can we? Okay. Okay. Yeah. So this trend is telling us clearly, like in the following years, think about the students that are enrolled in Berkeley, in Harvard, in whatever school, in the following years after they graduate, why they choose this major, what is to come in the future for them, right? And then if you transition your career or if you build up your career to launch something related to data analytics or machine learning or ahead of time, that's a good investment. And then the job roles in the domain. So we're going to skip too much detail, but like basically what is the knowledge and the core skills needed for different job roles. Like machine learning engineer emphasis more on the software engineering side or machine learning side. Well, data analyst may be more focused on data intuition, data visualization, communication, right? And then data engineer is more on the software engineer side. Well, data scientist might be more kind of a full stack scientist. Okay, then we move to the third part, is the career planning in the domain. And so what is the career track? What's the difference of being an individual contributor and someone interact more with people? Right? So traditionally, when people think about someone as a software engineer, it's mostly talking to the machine, talking to screen. Like you code and you design the system, you fix the bug. There's no too much need for talking to people. Well, when we think about traditionally someone in business background, it's always like attend many meetings, and talking to business partners, it's talking to people. Then it's data science or data analytics. It's the middle layer. You have the option to choose talk to machine more or talk to people more, right? So if you're more on the science focus or engineering focus, maybe the career track might be data specialist, data analyst, data scientist, senior staff principal. It's the same career track as individual contributors in the software development domain. Well, the other thing is that there are wider career options in later stage because of storytelling, because of communication, data visualization. You have a lot of chance to work on cross-team collaboration projects. You need to talk to project manager, tell them, based on my research, based on my model, based on my data, based on my dashboard, I suggest we have these following steps. Then you also need to talk to business development team, like marketing team, sales team, etc. What's the proposed solution? And in the meanwhile, you need to talk to software engineer because you collect the feedback and tell them how to better store the data, how to better design the system. So there is a kind of a two-door way. You can go ahead to talk to people more, or you can go ahead to talk to machine more. Here are some examples, like why data analytics, data science is important in different domains, and it's touching every aspect of our daily life. Let's say e-commerce, right? Black Friday, we have in China it's the similar way, and I believe in many countries there is a big celebration on certain day for their Prime member in all the famous commercial e-commerce site, right? So think about like supply chain, how to optimize and how to save the shipping labor, how to better plan the demand, right? For let's say Amazon or Alibaba, like where to set up the shipping hub, the center, and how many inventories they want to store ahead of time for the busy season. And then second thing, maybe like risk management. There are lots of bad guys on the website, like transaction safety and sellers misconduct, or customers complaints, customer review, how to have better have better performance to enhance the quality of their service. The third thing is the customer service. Let's say, what is the potential improvement for recommendations, right? And how to set up, let's say, shopping assistants. When we talk to Amazon, it's already fast enough to have someone pick up a phone. But isn't it better to have Alexa, or for Siri, Google Home, whoever, developing the new generation of shopping assistant to help the customer? So all these are related to model building, data analytics, machine learning, together with software engineers' efforts and business deployment. Another domain, take it as an example, is social network. So many companies are thinking about user growth, how to improve their content, how to do a better marketing strategy, and how to do their user engagement. Right? Snapchat is targeting at which type of audience by providing what type of content, why it's attractive to young generation. It's all backed up by data. Similarly, like risk management, how to detect and delete fake news, how to enhance business integrity, recommendation as well, news feed, right? So why am I seeing this news? Why am I reading an update of my friend on Facebook, on WeChat, on Instagram? And how to build a better community. Right? So social network is bring people tightly connected together in a new fashion. And we can achieve this by understanding the audience better. How? By the data. Right? By collecting their behavioral patterns and by building up the models or take advantage of the data resource we have. So just to take the two domains as an example, and then here I'm going to very briefly talk about the transformation, why data analytics could be beneficial for many people in different professional fields. So think about you're working in finance. It used to be like, hey, I predict this company's stock is going up. Then we used to not think about it too much because this guy is an investment expert. He knows a lot. He made money. That's why I trust him. But nowadays, it's a better way to do decision. Why I decide to invest money in this stock instead of the others? It's because I have the data. What's the performance for this stock? And more importantly, now you can even integrate more sentiment behind. There are many of the articles, or if you search on Google, on news, right? So what's people's attitude towards a company? Then you can infer investors' attitude towards that stock. And then it will help you to do better decision, whether or not to buy that stock. This is just an example for its application. We can reform and we can redefine like financial management backed up with some data analytics or machine learning. Similarly, like let's say for medical science or for biology, we have tons of sequencing data, right? So human's gene or the cell differentiation process. There are a lot of different functional confirmations of the sequence of the genome architectures and how to analyze those. It's always good to have better data storage and have better algorithms for us to have new exploration of the unknown world in medical science. So everyone can think about this is not something you need to shape yourself into. Like, hey, I'm a financial manager. I'm a professional working in financial management field. Now I want to do a transition. I want to become a data scientist. This is not the best way to think about it. Well, we can think about, hey, I'm a financial management professional, and now I want to advance my career. How? I have better data backed up my career. I have better data-driven mindset, have better data-driven solutions. So that's why data analytics program could boost your career. Yeah, so this is the brief introduction of the certificate program. It's only a 4 required course, and it's flexible hour with a friendly cost, and it's all online, and we'll get the chance to explore many of those topics together. Yeah, that's all we have for today, and thank you.
Thanks, Leo, for sharing